Hello viewers, in this video tutorial we are going to understand the proof of the power rule of derivative. So first, what says the power rule of derivative? So it says that if a function f of x is equal to x to the power of n, then its derivative represented as f prime of x is simply equals to n x to the power of n minus 1. So let's try and investigate why this is true. And to do that, we are going to consider using the definition of derivative. So from the definition of derivative, for any function f of x, then the y dx, which is equals to f prime of x, is simply equals to the limit as h approaches 0, where h is the same as delta x or change of x. They are often used interchangeably. Okay, perfect. Limit as h approaches 0 of f of x plus h minus f of x all divided by h. So this is the definition of derivative, which is also called the first principle. Okay, perfect. Now, if f of x is x to the power of n, what would be f of x plus h? Well, what f of x plus h means in essence is that wherever you find x in f of x, just replace with x plus h. Okay, good. So therefore, if f of x is equals to x to the power of n, then f of x plus h will be equals to x plus h all raised to the power of n. So instead of x, I have x plus h. Perfect. So having all this, we can plug in the corresponding values in the formula we stated earlier. So therefore, f prime of x will now be equals to the limit as h approaches 0 of x plus h all raised to the power of n minus x to the power of n, then entirely divided by h. Perfect. Now at this point, we can begin our simplification. But before we can simplify this, we need to focus more on this. This is a binomial with a degree n, which is unknown. So we can't really expand it by just ordinary algebraic process or by Pascal triangle. So in this kind of situation, the best thing to do is to use a theorem called binomial theorem. So what says that theorem? So the binomial theorem says that when you have a binomial, a plus b, to be raised to an index, okay? To expand it, then the expansion will be the summation from r equals 0, where r will be approaching the index or the power n, okay, of n combination r as r is increasing, then of the first term a raised to power n minus r, then multiplied by the last term of b, second term, which is raised to power r. Okay. So this is what the binomial theorem says. And we are going to use that idea to expand x plus h to the power of n. So therefore, if this is true, then s plus h to the power of n will simply be equals to the summation from r equals 0 all the way to n of n combination r x to the power of n minus r, then h to the power of what? H to the power of r. Okay. Now what we are going to do is that we are going to consider some values for r when r is 0, 1, and 2, and see what the expansion will look like. So when r is 0, we have n combination 0, okay, then multiply by x to the power of n minus 0, okay, then multiply by h to the power of 0. Perfect. Now this symbol means summation. It means when we begin the expansion, then each term must be connected with positive sign. So we have plus when r is 1. That's n combination 1. So that will be x raised to the power n minus 1, x to the power of n minus 1, then h raised to the power 1. Perfect. So again, the symbol plus. When r is 2, n combination 2, okay, 2, okay, perfect. Then x to the power of n minus 2, then h raised to the power of 2. Now as you can see, as r increases, then it keeps on adding value. Now we keep on writing this if we don't want to stop. It's in fact it goes to infinity because n doesn't have an end. So therefore, I'm just going to represent that with plus dot 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 dot. That is, it doesn't have an end. Perfect. So now, instead of x plus h to the power of n, I'm going to replace that with this. But to keep it short, let me simplify this 3 times first. So what is n combination 0? So whenever any value is combined with 0, then the result will be 1. Okay? Note, n combination r is simply equals to n factorial over n minus r factorial multiplied by r factorial. Okay? The same requires here. In case of place, I might have question on how I got 1. Okay? And that's just the only one I'm going to simplify. So when r is 0, n combination 0 equals to n factorial divided by n minus 0 factorial over 0 factorial. Okay, and this is expressed like that is before. I'm going to just let it. So we have n factorial over n minus 0 factorial is n factorial. As you can see, the cancels and we have 1. And that's how it will always work for any value that is combined to 0. And for this one, I'm wondering what the factorial means you should be multiplying that value with the numbers before it all the way to 1. Okay, but she keeps on multiplying with the value that comes before it all the way to 1. So for instance, you have 3 factorial. That simply means 3 times what number comes before 3? That's 2. Again before it, that's 1. So when you reach 1 stop, you multiply them together. That's what 3 factorial means in x6. Okay, perfect. So let's just keep that in mind. For this, I'm having question on that. Perfect. So now I'm simplifying forward. N combination 0, we said that will be 1, and h raised power 0 is still 1, n minus 0 is n. So everything this time entirely is just x to the power of n. Let's write it in x to the power of n. Okay, plus, are we there? Perfect. Now, n combination 1, let's do that. N factorial over n minus 1 factorial, then 1 factorial. Now 1 factorial is still 1, just leave it. That's right. Now n factorial can be simplified to n multiplied by n minus 1 factorial. It's just like me finding the value that is smaller or that comes before n immediately. To get that value, I'm just going to subtract 1 from it. And divided by n minus 1 factorial. You can see that this cancels, left over is n. So therefore, n combination 1 is just ordinary n. Okay, perfect. So we have n, then multiply by what? Multiply by s to the power of n minus 1, then h raised to power 1, which is h. Then plus, now n combination 2, that will give us n, multiply by n minus 1. Okay, we have s to the power of n minus 2, and multiply by h squared plus dot 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 dot. So you can show this by the formula I showed you earlier. That is what the result will be. Perfect. So now instead of s plus h to the power of n, I'm just going to replace with this. And therefore, we now have f prime of x to be equal to the limit as h approaches 0. Okay, this replace with this. Okay, now the x to the power of n plus n x to the power of n minus 1 plus n minus 1 x to the power of n minus 2 h what? H squared. Then this is divided by 2. Okay, it's divided by 2 because it's n combination 2. If you have 2 factorial, just keep that in mind. If you use the formula, you should see where the 2 is coming from. Okay, good. Now plus dot 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 dot. Keep in mind, they are separated. Perfect. Now let's simplify forward. Okay, so this is equals. Okay, I'm not through. We are not through. So minus, what should I write that? I'm out of space. So let me just put it there, minus x to the power of n. This is the one I wanted to write. X to the power of n, and everything entirely is divided by h. Good. Now I will write that so you can clearly see the clear image. So we have the limit as h approaches 0 of x to the power of n plus n x to the power of n minus 1. Okay, if you are following, plus n minus 1 x to the power of n minus 2 h squared divided by 2. Alright, then plus dot 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 dot. Then we have this minus x to the power of n, that's minus f of x minus x to the power of n. Perfect, and everything entirely is divided by h. I can clearly state that at this point, okay, h is here. I think so. Yeah, h is here. I omitted that. H is here. Okay. Now x to the power of n cancels negative x to the power of n. As you can see, they repeat themselves. So left over, we are going to write that right here. So therefore, right now we now have f prime of x so now be equal to the limit as h approaches 0 of this is the limit we are left with n x to the power of n minus 1 multiplied by h. Okay, perfect. Then plus this n multiplied by n minus 1 over 2, then s to the power of n minus 2 h squared. Okay, then plus dot 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 everything entirely. Oops. Divided by h. Good. Now, simplifying forward, what should we do at this point? You can see that as this value increases, there will be h to be associated with it. As you can see, h is raised to the power of 1 here. Then when you move to the next one, h is raised to the power of 2. It means as it is increasing, h will also be increasing in index. So therefore, if you factor out h, there will still be h in some of them without the dot dot dot. You really don't need to pay attention in those parts. Okay. So therefore, factoring h out, we have the limit as h approaches 0 of h multiplied by n x to the power of n minus 1 plus n minus 2 all divided by 2, then s to the power of n minus 2. H, we are factor 1 after it, so we are left with just 1. Then just plus dot 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 dot. Okay, then closing bracket entirely divided by h. Okay, okay. Right now, the h can cancel out. I will be left with the limit as h approaches 0 of n x to the power of n minus 1, then plus n multiplied by n minus 2 raised to the power n minus is n minus 1. Okay, n minus 1. So raised to the power n minus 2 h plus dot 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 dot. Okay, divided by 2. Perfect. Now you can see there's no h term associated with this term, so we can take it out of the limit because it's serving as if it's just trying to add the limit because it's not having h term. Okay, so let's take it out. N x to the power of n minus 1, then we have the limit as h approaches 0 of what? Of n multiplied by n minus 1 up to the power of n minus 2 h or divided by 2, okay, then plus dot 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 dot. Now, like we said earlier, each term we'll be having within this range will always have h to be associated with it. It means if we plug in what h is approaching, which is 0, then this entire expression becomes 0. And therefore, we'll be left with, okay, don't forget this is plus, we are adding plus, okay, this is plus, we have to brought it out more times, that's it plus, just bring the limit, so we have n x to the power of n minus 1 plus 0, which is the same thing as n x to the power of n minus 1. And that is how f prime of x is equal to n x to the power of n minus 1. And this is our final answer. And that shows out why the derivative of f of x equals x to the power of n is equal to n x to the power of n minus 1. Now, I actually need to make a justification before ending the video. Some are wondering why I put positive sign here. Because from properties of the limit, then I get here the limit, okay, as let's say x approaches 2, alright, of x squared plus 2x is the same as the limit as x approaches 2 of x squared plus the limit as x approaches 2, okay, of what? Of 2x. Okay, so that's one of the properties of limits. So that's what I use right here. Since this doesn't have h term, I tend to bring it out. If I do the limit of it, the answer will be this because there's no terms to multiply with. You understand? There's no term to like there's no h term to plug in for 0. You understand? So that is why this can be brought out. Okay, and that's it. And now you know how the power is formed. If you have any questions, feel free to let me know in the comment section below. And thank you. See you some other time. Bye for now.